In this video, we will cover adjusting electrical settings and creating circuit naming schemes. In Revit, there are several electrical settings that affect many aspects of the electrical design process. To access the electrical settings, switch to the Systems ribbon, and then on the electrical panel, click the dialog box launcher. In the Electrical Settings dialog, there are several settings. For an in-depth look at every single setting, take a look at Revit Help. We'll cover some of the important settings you should focus on when setting up your projects. The hidden line settings control the hidden line style and gaps that are used when elements cross underneath one another in your views. In the general settings, you can specify the electrical connector separator. Then you can choose an option for the electrical data style. This controls the format of the electrical data parameter. I'll click OK and then select a lighting fixture. When I scroll down in the Properties palette, you can see the electrical data parameter. Once again, that setting we just looked at affects the formatting of this parameter value. I'll switch back to the Electrical Settings dialog, and then we'll continue on. The Circuit Description parameter specifies the format of the Circuit Description parameter, which is available for wires. Then you can control the circuit naming by phase for phase A, B, and C labels. These values are only used if you specify the circuit naming by phase for a panel. Next, you can control the option used for capitalization for load names. For example, it can be set to from source parameters, or only initial caps, or sentence capitalization, or everything in upper. Next, you can control the circuit sequence. This controls the sequence in which power circuits are created. So if you want to create them by phase, or odd then even, you can select one of those options. Or leave it set to numerical and it'll go in numerical order. The circuit rating is the default rating for circuits. So when you create a circuit, it will be a 20 amp circuit by default. And so if you, depending on what project you're working on, you may want to change that to 30 amp or whatever it may be for your project. Similarly, the circuit path offset is the default path offset for circuits. In the Angles settings, you can control the angles used for conduit and cable trays. You can select Use Any Angle, and Revit will use any angle that the fitting families can adjust to. You can choose Set an Angle Increment, and then specify a specific increment, or you can choose to use specific angles, and then there's a table here, and you can select and deselect the angles that are used. So maybe you want to narrow it down to 90 degrees and 45 degree angles, and you could do that here. In the wiring settings, there are several options here. The ambient temperature, that should be the temperature that the wiring will exist at. And then you can control the gap of wiring crossing. So if they cross in a view, what gaps is going to use. And then you can control tick marks and slanted line across tick marks, and other options at the bottom for how the wires will appear. Some important ones you should be aware of is the maximum voltage drop for both branch and feeder circuits, and this is the maximum percentage of voltage drop allowed for either branch circuit wiring or feeder circuit wiring. In the wire sizes settings, there are some important settings you need to specify here. This is where you can control the material, the temperature, and the insulation types. And we'll see where these are used more here in a minute. And you can also create new ampacities or delete existing ones that exist in this table. And so when you create a new ampacity, you can specify the ampacity, the wire size, and the diameter. And you can control these for each material, each temperature, and insulation type. In the correction factor settings, you can select a material and temperature and then define correction factors. And once again, you can create new or delete correction factors. And continuing on, in ground conductors, you can select a material and then create a conductor size for various ampacities. And then in the wiring type settings, you can control your wire types. And so many types are controlled in the type properties dialog, but for wires, those are controlled here in the electrical settings dialog. And so when you create a new wire type, you can give it a name, and then you can select a material, a temperature, and an insulation. And these are what were controlled in the wire sizes settings. You can also control the maximum size, the neutral multiplier, whether or not neutral is required, and then for the neutral size you can set it to hot conductor size or unbalanced current. And then the conduit type can be set to steel or non-magnetic. And you can delete wire types as well. For voltage definitions, you can control the voltage definitions that will be used for the distribution systems. And so these are important here because you can control the minimum and maximum values for a voltage definition. So we see several commonly used voltages here, and you can see that, for example, for 480 volt, the min is 460 and the max is 490. So if we have something in that range, it will be used for the 480 volt definition. Then in the distribution system settings, you can modify existing distribution systems or create new distribution systems. Here you can set the phase, it can be single phase or three phase, and the configuration can be Y or delta. And then for single phase distribution systems, it can be 2 or 3 wires, and for three phase it can be 3 or 4 wires. Then you can set the line to line voltage, and you can select a voltage definition, and a line to ground voltage, and once again you can select a voltage definition. And so these are important for circuiting to make sure that your voltage definitions are specified correctly, and then your line to line and line to ground voltages are specified. Continuing on, there are cable tray settings and conduit settings that are very similar. You can control whether or not to use the annotation scale for single line fittings, and if you do, then you can specify the fitting annotation size, and that can be for both cable tray and conduit. Take note that if this option is selected, it will only affect the use annotation scale parameter for fittings placed after that. So in other words, if you toggle this option on or off, it does not affect existing fittings. You can then control prefixes, suffixes, and separators for both cable tray and conduit. Next, you can control the rise-drop annotation size, and then single line and two line rise-drop symbology. And then on the size settings, you can control the size of cable tray and conduit. In the panel schedules options, you can control the spare label and the space label, and these are text fields, and you can enter in whatever value you want. And then you can choose whether or not to include spares in panel totals, and you can choose whether or not to merge multi-poled circuits into a single cell. And lastly, you can create circuit naming schemes. And we'll take a look at this. I'll create new scheme, and here you can add parameters that will be used. So for example, I will select panel and click add parameters, and then I'll select slot index and click add parameters. And down here at the bottom I can see a preview of the value. So this will just be panel right next to slot index. So I'll add a separator, I'll add a slash in there, and now you can see my updated preview here. And I will name this panel and slot index, and then click OK. And then I can use this circuit naming scheme. So as you can see, there are several electrical settings, and you should take a look at those when you are creating your project so that your design will progress as you want it to.